Hello, Algebra 2! I hope you guys are having a great day! I definitely am. This is my second video in the last 20 minutes. Hour. Last one took me about an hour. Anyways, 5-6 we're moving on to, which is talking about radical expressions. And in case you don't know the vocab word, radical is the same thing as the root, right? But maybe it's not a square root anymore or a cube root anymore. Maybe it's a fourth root or a fifth root or a sixth root or a seventh root or 155th root. Okay, so I'm just going to do a little refresh of some of the properties of roots, and then just do a couple examples. And basically what we're going to be doing with those examples is taking square roots and changing them to exponents, and changing exponents into square root, not square roots, sorry. Exponents to roots, roots to exponents, and simplifying things if we can. So here we go. Remembering roots. We know about square root. Okay, we already talked about that. So how do we plug them into the calculator if it's not an obvious answer? So that's going to be the question that we're going to be answering today, part of the question that we're going to be answering today. So if you take a look at the following examples, square root of 25, you know, is just 5, right? Because it's what times what equals 25. So example 1 equals 5. But similarly, example 5, which is right below it, square root of negative 25, right? We can't do, because you can't have a number times itself be a negative number. That will never happen. So that's undefined. Now, on the other hand, cube roots, because we're taking 3 numbers and multiplying by each other. I can't talk today. You can have the cube root of a negative number or a positive number. Right? So the cube root of 27 is what number times itself 3 times equals 27? Well, that number is 3. Cube root of negative 27 is negative 3, because negative 3 times negative 3 is positive 9, times another negative 3 is negative 27, okay? Fourth root, okay? What times itself 4 times equals 16? Well, we could try 4, but 4 times 4 is 16. That's only 2 times. So how about 2? 2 times 2 is 4, times 2 again is 8, times 2 again is 16. So the fourth root of 16 is 2. Now, similar to the square root of a negative number, the fourth root of a negative number is also undefined, because if you have an even number of values that you're multiplying by each other, right, if all of them are negative, you're going to have a positive number. If all of them are positive, you're going to have a positive number. So there's no way you could get a number times itself 4 times to be a negative number. So really what this shows us is that any time you have an even root of a negative number, it's going to be undefined. But an odd root is okay. So odd roots will be defined. So that brings us to the last example. The fifth root of 32. What times itself 5 times is 32? Well, again, I'm going to go with 2, because let's try it and see what happens. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That was 5 of them, and that equaled 32. So the fifth root of 32 is 2. Fifth root of negative 32, again, because it's an odd root, you can do negative 2 times negative 2, which is positive 4, times another negative 2, that's negative 8, times another negative 2, that's positive 16, and then times negative 2 is negative 32. Okay, so you can actually have that answer, and it'll be negative 2 is the fifth root of negative 32. Okay, let's go into a couple properties of roots. So the first one is that the root of a product meaning multiply, root of a product, so the square root of 2 things multiplied together, is equal to the product of the roots, which is multiplying 2 roots together. So basically, if it's multiplication on the inside of a root, then you can break it up into 2 separate roots with multiplication. So I'm going to write that down in algebra terms and then show you 2 examples of what that actually looks like with numbers. So the algebra version of this is that the square root of x times y is equal to the square root of x times the square root of y. Now you guys have already seen this in class, like we've already done problems with this, but it's just kind of solidifying that actual rule. And so basically what we can do is, for example, simplify, this problem says simplify the cube root of 16. And so we can break 16 up into something like, we can do the cube root. 16 is equal to 8 times 2. And I know that the cube root of 8 exists. So since I have two things multiplied under a root, then I can take that and make it a cube root of 8 and multiply by the cube root of 2. So my final answer then is cube root of 8, which is 2, times the cube root of 2. And that would be my simplified answer for the first one. Second example is the square root of 242. Now, I can tell that that's divisible by 2, so I'm just going to go ahead and write that as the square root of 242 divided by 2 is going to be 121 times 2. Oops, and it's the square root. So then I can break that up into the square root. I don't know why I'm writing a 2 there. 121 times the square root of 2, right? Square root of 121 is 11. 11 times 11 is 121. So we have 11 times the square root of 2. So that would be our simplified answer for number 2. Next rule is that the root of a quotient is the quotient of the roots. So this is similar to the multiplication one, except now it's with quotient, which means division. So you've got the root of a quotient, which means we have any root. I'm just writing in the square root, but it can be the nth root, third root, fourth root, fifth root. It can be any root of x over y, right? They're inside the root, both of them. We can break that up into the root over a root. So the nth root of x over the nth root of y. And we should actually probably have the nth root for the multiplication one as well, because it works for any root, not just the square root. Okay, so let's do a couple examples. All right, cube root of 16 over 25. It's not going to really simplify much, but we can break that up into the cube root of 16 over the cube root of 25. 16 is 8 times 2, so that becomes the cube root of 8 times 2, and over the cube root of 25. And then we can break that up using the first rule to be the cube root of 8 times the cube root of 2, ends up being 2 root 2, cube root of 2, all over the cube root of 25. 25 does not break up because it's just 5 times 5. That won't be simplified anymore. So, but you can rewrite it like that. Second one, simplify the square root of 100 over square root of over 25. Since both are under the root, we can make that the square root of 100 over the square root of 25, which simplifies a lot nicer than the first one, to be 10 over 5, which is just 2. Box it, done. And last but not least, you can write roots as exponents. So the nth root of something is equal to that something raised to the 1 over n power. What's really nice about this rule is that if you need to simplify it in your calculator and you don't have a cube root in your calculator or a fifth root in your calculator, you can just plug it in as 5. So this is a cube root of 5 is the same thing as 5 to the 1 over 3. So you can actually plug that into your calculator and get an answer. So 5 raised to the 1/3 power, I'm going to put it in parentheses just so I make sure that it stays in the exponent, is equal to 1.7099. So, you'd round it according to whatever the problem tells you to do. So I'd write maybe 1.71 approximately. And for number 2, simplify the fifth root of x squared. This isn't really much simpler, but really what you can do is you can take that x squared and raise it to the 1/5 power, and then raising an exponent to an exponent right? You just multiply them together. So that becomes x to the 2 over 5 would be another way to write that. If you need a reminder on the other exponent rules, please look at this chart or come to me during office hours to make sure you refresh those, because I'm going to assume that you already know them because that's from like Algebra 1. So anyways, moving on. I would recommend pausing at this point and trying these problems on your own first, then looking at my solutions. All right, example 1a, we have the cube root of 27 times x cubed. Using the first rule, we can make that the cube root of 27 times the cube root of x cubed. Cube root of 27 is just 3. And the cube root of x cubed, remember cube root and the cube cancel each other out because they're inverse functions of each other. Or if you need a refresher, right, you have x cubed raised to the 1/3. Multiply exponents, you get 3 over 3, x to the first. So that ends up being just x. So the cube root of 27 times x cubed is 3x. Fourth root of 32 over x to the 4th. You can separate that using rule 2 as the fourth root of 32 over the fourth root of x to the 4th. And again, fourth root of 32 is just 2, I believe, because 2 times 2 is 4, times 2 is 8, times 2 is 16. Oh, it's not. We have one left over. So we have a little more work to do. Fourth root of 32 is the fourth root of 16 times 2. And the fourth root of x to the 4th is just x. And then that becomes the fourth root of 16 times the fourth root of 2. So that becomes 2 times the fourth root of 2 all over x. And that, my friends, is my final answer. All right, example 2 says write each expression in radical form and simplify. We got 32 to the 3 over 5. I can actually rewrite that as 32. You can rewrite it many different ways. One option would be to take 32, raise it to the 3rd power, and then to the 1/5, right? Because 3 over 5 is just 3 times 1 over 5. So I could just rewrite it like that and make it the 5th root of 32 cubed. But this doesn't make as much sense because 32 cubed is a huge number, and then that's a pain in the butt. So instead, I'm actually going to go the opposite way. I'm going to go, because multiplication can go either way, right? So I'm going to do 32 to the 1/5 raised to the 3rd power. That becomes the 5th root of 32 raised to the 3rd power. And then I have to find out what the 5th root of 32 is. I already did that, right? 2 times 2 times 2 is 8, times 2 is 16, times 2 is 32. So the 5th root of 32 is just 2, and I'm raising that to the 3rd power. That whole thing just equals 8. Here are the solutions for the rest of them. For the sake of time, I'm not going to talk through them. Let's go to example 3. It says write each expression using rational exponents. Rational being a fraction. So I've got the 5th root of 7 to the 10, and the 5th root I can rewrite as the power 1 over 5. So let's do that, which is the same thing as 7 to the 10 times 1/5, right? So that becomes 7 to the 10 over 5, which is just 7 squared. 10 divided by 5 is 2. 49. Box it. Here's the solution to B. Example 4 is just asking you to simplify each expression. This is 3 to the 3/5 times 3 to the 1/5. If you're multiplying and you have the same base, just add the exponents. This becomes 3 to the 4/5, which doesn't actually simplify anymore. So this one, I would notice that both have a 1/2 power, so I'd pull that out first and simplify as best I can. This would be one way to go about getting the answer for B. And then I'll show you the answer for C as well. And that would be the answer to C. come in if you have questions on old stuff, and we'll go more over this in class.